Students, very good morning to all. Myself, Dr. G.B. Dawke. Today, we will discuss about the topic on the linear differential equations with constant coefficient. This topic depends upon the differential equation. So this is one of the types which we study the differential equation. First of all, what is the meaning of differential equation? Before that, we will study what is the meaning of equation. Suppose there is a x plus 1 is equal to 0. That type of expression is called as the equation. So, this can be written as x is equal to minus 1. That type of expression is called as the equation. Again, other example, x square plus 1 is equal to 0. This is the other equation. Before that, we will see what is the meaning of differential equation. An equation containing derivative. An equation containing derivative is called as the differential equation. For example, dy by dx plus 2y is equal to 6x. That type of equation is called as the differential equation. Why it is called as the differential equation? Because this equation containing the derivative. Where is the derivative? This is the derivative. Derivative of y with respect to x. If equation containing one of the term including derivative, that type of equation is called as the differential equation. So this concept is clear. Now, after that we will see what is the meaning of linear. So, linear concept is related to the order and degree. Okay, it is related to that is degree. Suppose equation is d2y by dx square plus dy by dx plus 6y is equal to 4x. This equation containing two terms which having derivative. Its meaning is what? Derivative of y with respect to x 2 times. Its meaning is what? Derivative of y with respect to x 1 times. So what is its degree and order of this equation? This differential equation differentiate 2 times. So this term will differentiate 2 times, this term differentiating 1 times, this term not differentiating, this is also not differentiating. Y is a dependent variable, x is the independent variable. Okay, so after that, see here, highest differentiating term in this equation is 2 times, hence its degree is 2. Its degree is 2 and order is 1. Just check its power. Its power is 1, so because of that, its order is 1 and its degree is 2. So we see the other example. What I am saying this, because I am saying this, what is the meaning of linear? What is the meaning of linear? For that purpose, we know that what is the meaning of derivative and what is the meaning of order and what is the meaning of degree. So now next, d to the power 3 by dx to the power 3 2 times. Next, d to the power 4 by dx to the power 4 plus 7y is equal to 6x. So this term containing total 4 terms. First term, second term, third term, fourth term. This term differentiating 3 times. This term differentiating 4 times. This is not differentiating term, this is the variables. So highest differentiating term in this equation is 3 times. Highest differentiating term in this equation is 4 times. So highest is the, out of them 4 is the highest. So order of this equation, order is 4 and degree is, order is 4, degree is 2. See here, its order is 4 and its degree is 1, its degree is 1. Okay. So, what is the meaning of linear? Linear means what? Those differential equation whose degree is 1. Its order, it may be 1, 2, 3, 4, 5, 6 up to the n. There is no restrictions on the order, but there is restrictions on the degree. Those differential equation having degree 1, that type of equation is called as the linear differential equation. Okay, differential equation is what? Equation containing derivative is called as a differential equation, and linear is what? A differential equation having degree 1 is called as a linear differential equation, and constant coefficient means what? These are that type of equation. For example, a1, a2, a3, that type of constant is called as the constant coefficient, or 7, or if you suppose there is 6, then 6, that type is called as the constant coefficient. Okay, so I will take a general form of a linear differential equation. General form of a linear differential equation of the form d to the power n by dx to the power n, a1 d to the power n y by dx to the power n, plus a2 d to the power n minus 2y by dx to the power n minus 2, a3 d to the power n minus 3 by dx to the power n minus 3, plus so on an y is equal to q of x. That type of equation is called as a linear differential equation. See, its order, because this equation differentiating n times. So this term will differentiating n times, this term will differentiating n minus 1 times, this term will differentiating n minus 2 times, this term will differentiating n minus 3 times, plus so on. So out of that, highest is this n. Hence, its order is n, and its degree is 1. See, its power is 1. So its degree is 1 and its order is n. So this is the linear. Linear is what? Differential equation having degree 1 is called as the linear differential equation. And there are a1, a2, a3, an are the coefficient. Hence this is called as the linear differential equation with constant coefficient. Now, for every differential equation there is one operator that is called as the differential operator. Differential operator denoted by D. We will operate the differential operator to this equation. Then this equation we will call this equation number 1. So this equation it will becomes d to the power n y by dx to the power n, or d means what? D by d. Next, d square means what? d2 by dx. dq means what? d to the power 3 by dx to the power 3. That's all. So you will get d to the power n y plus a1 d to the power n minus 1. We will take y outside, common, d to the power n minus 2, a3 an, here y is equal to right hand side q of x. So both equations are the same. Just I have applied the what operator for this equation number 1. Then equation number 2 it will become in this way. Now, depend upon the root of this equation. There are mainly 3 types. First type is the roots are real and distinct. Second, roots are real and safe. And third, roots are complex. So depend upon the differential equation, there are 3 types, that is roots are real and distinct, roots are real and safe, roots are complex number. Okay. So after that we will see one by one. Suppose differential equation is having n order and degree 1, that is linear differential equation. Then roots are, first, roots are real and set. Real and different. Suppose linear differential equation having n order, then its roots are a1, a2, a3, a4, an. Then its solution is provided as a complementary function. Its complementary function is c1 first root into x, c2 second root into x, c3 third root into x, cn e to the power nx. Suppose second time, roots are real and set. Real and set. Then suppose a1 is equal to a2 is equal to a3. Three roots are the same and remaining are the different. Then its complementary function is c1 c2x c3x e to the power, take either a1x, a2x or a3x because three numbers are the same, plus c4 a4x c5 e to the 5x plus cn e to the power anx. So roots are the real and set. So last, roots are the complex. Then suppose there are roots are complex. Roots are complex. Suppose two roots are the same complex and then roots are the real, then its complementary function is e to the power ax. Complex number we know that z is equal to a plus minus ib. Then e to the power ax, a is the real part, c1 cos bx, c2 sin bx. A is the real part and b is the imaginary part. And remaining part, the roots are the different, real and different. c1 c2 is over, now c3 e to the power, suppose a3x, c4 a4x, cn e to the power anx. In this way, so there are three categories depend upon the root of the differential equation. Okay, so we see roots are real and set. Then how to solve examples? We will take one more example. Suppose equation is d square minus 5d plus 6y is equal to 4x. Example number 1. So solution. First you will find its root. Its auxiliary equation is just instead of d write down m square or keep d as it is, no problem, minus 5m minus 6. Don't take y and take right hand side is equal to 0. Just find the root of this equation. Its root is m minus 2, m minus 3 is equal to 0. So you will get m is equal to 2 comma 3. Both roots are the real and different. Then its complementary function is c1 first root into x, c2 or complementary function c1 e to the power 3x, c2 e to the power 3x. Again, for more example, depend upon the three types that we will see in the next video. Thank you.